Hello. In this video, I'm going to do a quick review of some of the integration methods that you should have learned in Calculus 1, and starting out with some of the basic formulas for integration. So here are the very first ones that you're usually introduced to in a Calculus 1 class. The most important ones are probably those last four. The third one, where I have something to a power, so like x squared or something like that, often referred to as the power rule. That's when I integrate. I'm going to add 1 to the exponent and then divide by that new exponent to get the answer for that integral. Also, another one that we run into a lot in this class is when I have 1 over x, or 1 over x plus 3 or something like that. And for that one, you get the natural log of the absolute value of whatever's in the bottom there. And then e to the x is that second to the last one, another one we run into an awful lot, and luckily is a pretty easy one. The integral of e to the x is just e to the x. And then the last one, I don't run into this too much, but every once in a while, if you have a constant to a variable, so something like 2 to the x, you can see the formula there. I would get, if it was 2 to the x, I would get 2 to the x over the natural log of 2 for my integral. So I'm just going to do a quick example, particularly of the power rule on this one. So here I just have a straight polynomial. So each one of these I'm going to be able to do the power rule on to integrate. So that first one, I'm going to add 1 to the exponent. So it becomes x cubed becomes x to the 4th, and then divide by 4. And then do that with each one. So the next one will become x cubed over 3, and then x squared over 2, and then 4 times x for that last one. So here's what I get just from integrating it, and then I can do a little simplification, particularly that first fraction, 2 over 4, I can reduce to 1/2 to get my final answer. So that's what the power rule looks like. Another really important skill that you want to bring from Calculus 1 is U substitution, and that's why they were used in all of those formulas that I showed in that first screen of formulas. Is for when we get something a little bit more complicated. So here I've got a lot going on. I do have that square root, which is 1/2 power. So I'm hoping at some point I can do a power rule here, but I'm going to have to do a U substitution to simplify it a little bit. Usually you want to choose U to be something that's inside of another function. So looking at this one, I want to make the U equal to the x to the 4th plus 1, since that's inside of a square root. And then I'm hoping when I take the derivative to swap out that differential, the dx, that will take care of that 2x cubed that's out front as well. And luckily that is exactly what happens here. If U equals x to the 4th plus 1, then the derivative of that would be 4x squared dx. And there's a few different ways to think about how that substitution works. I tend to think of it as just a swapping out of a one thing for another. So I see that I have a 2x cubed dx in the integral, and I have a 4x cubed dx equal to my du. And so I try and get the two sides, the right side, to look just like what is in the integral. Which means that I want that 4 to become a 2. And so I can do that by dividing both sides of this equation here by 2. So I get 1/2 du is equal to 2x cubed plus dx. So that means when I go to do the actual substitution here, the 2x cubed dx gets replaced with 1/2 du. Now, if that isn't the way you think of how the substitution works, that's fine. Do it the way that works for you and that makes sense. But after I do that, so the 2x cubed dx is swapped out for a 1/2 that's I put out front, and the du at the end. And then the x cubed plus 1 is rewritten as u, and then I used a 1/2 power instead of the square root symbol, just because I like to use power rule here. So I've done the u substitution, and now I can do power rule on what's left. So I add 1 to the exponent, so 1/2 plus 1 is going to give me a 3/2. And then divide by 3/2, which is the same thing as multiplying by 2/3. So I end up with this here. So I still have the 1/2 out front, and then I have 2/3 u to the 3/2 plus c. So I'm almost done at this point. I need to do a little simplifying here of those fractions, and I need to reverse the u substitution. My integral started out in x, so I need my answer to end up in x as well. So if I just swap out the u for what it was equal to, the x to the 4th plus 1, and then simplify those fractions, I end up with 1/3 times that x to the 4th plus 1, all to the 3/2. Don't forget about that 3/2. And then plus my constant of integration, of course. So that's how U substitution works. The last one I want to review for this, review for 5B is some trig formulas. We are going to see a lot of trig formulas in this class as well, especially in this very first unit. So having these down is pretty helpful. Most of these we remember just from remembering the derivatives and thinking of these as antiderivatives. So that's where most of these formulas come from, except for the last three. Tangent of U and cotangent of U, we don't run into those too often in this class, but they're nice to have. This last one is one you may not have seen before, but is super helpful in this class. It just tends to pop up a lot. When I have 1 over something squared, a constant squared plus an x squared or a u squared here, then I get this tangent inverse function. And so this one's one that tends to pop up a lot in this class. So it's just a nice one to have memorized when, over the course of the semester. So we'll just do one more example with this, with some trig functions. So I have secant of 3x times tangent of 3x dx. And if I pop back just for a second here, secant times tangent, that is the derivative of secant. So I'm going to be able to use that here. The 3's kind of throw things off a little bit, which means I'm going to have to do a U substitution. So I'm going to start off with that U substitution with kind of have this plan in my head that I'm going to end up with a secant of something with some constants in there for my final answer. So I'm going to let U equal 3x, which means that du is equal to 3dx, just the derivative of 3x. And I don't have a 3 out front in this integral, so I'm going to divide that 3 over. So now the dx is going to get replaced with 1/3 du when I do my U substitution. Okay, so I throw that 1/3 out front, and now I have secant u times tangent u du. And I can go ahead and integrate this. So again, the derivative of secant is secant times tangent, so the antiderivative of this will be secant of u with that 1/3 out front. And then the last step is to just reverse that U substitution. So swap out the U for the 3x, and I get my final answer. Okay, so this should give you a pretty good starter, just refreshing our memory on Calculus 1. I do have a couple of more guided practice examples from the guided practice notes that you can try out to make sure you've got all these concepts down and are ready for new material in Calculus 2.